So I just wanted to briefly discuss another example that may not be obvious at all that we could use a network for, and that is a machinery problem. And so the idea behind this machinery problem is that we want to have a machine for about 5 years. We could buy a machine now and purchase replacement costs, some kind of replacement purchase price, maintenance cost, I guess is what I want to say, for 1, 2, 3, 4, or 5 years. The problem is, of course, is the maintenance fees are increasing as you age the machine. And so therefore, at what point does it become profitable to just go ahead and buy a new machine? And so we have some different costs here that we can look at. So our year, and then we have a maintenance cost, which goes up, and a purchase cost, which also goes up. Okay, so 1, 2, 3, 4, 5. Good. And so then it's 38, 50, 97, 182. Boy, there's a big jump there. 304, big jump there. Okay, so then 170, probably in thousands maybe if it's a farming equipment or something like that. 190, 210, 250, 300. Okay, so let's take a look at some examples here. And so some extreme examples, just to kind of cost it out. So suppose I purchase a machine year one, and just maintain it for the 5 years. Okay, so then I would have, what would my cost be? $170 for the purchase price, and then I would have $38 for the first year, and then $50, $97, $182, $304. Okay, so that gives me a total of $841. Okay, now what's the other extreme? Purchase every year. Some people do this with cars. Purchase every year. So then you're going to be taking 170 plus 38. But then we're going to take 190 plus 38. Then we have 210 plus 38. You get the idea. Plus 250 plus 38 plus 300 plus 38. And that's going to be equal to, that's the expensive one, right? 1310. So we should be able to do better than that, of course. And that's right in the ballpark there, maybe. Okay, so then we need to figure out what kind of the general situation is here, and then try to get some notation for it. And the notation is where things really are critical. You want to define your notation correctly. And so we're just going to use this as maybe a hint. Let Cij be our variable, where we're purchasing on year I. Purchase year I, and then we're going to buy a new machine at the beginning of year J. Okay, and so for example, C11 wouldn't really make sense in this situation, right? But C12 would, and so C12, right, would be that situation where we're buying year one, we're keeping it year one, and then buying a new machine year two. So that would be the 170 plus 38. And similarly, what would C13 be? That would be our 170 plus 38 plus 50, and so on. Okay. What would C23 be? C23 would be a purchase year two, and then we're purchasing new for year 3, so that'd be 190 plus 38, right? So similarly, C24, 190 plus 38 plus 50, and so on. Okay, and then we just continue that. So what's our last variable going to be? I believe it's going to be C56, right? So that would be our last purchase. And what would that be? What's our last value there? 300 plus 38. Oops. 300 plus 38. Okay. So therefore, what I've got here is I've got all the nodes going from the integers 1 through 6 to all other nodes. And so my network is going to look like a big mess, kind of. Maybe 1, 2, 3, 4, 5, 6. And so I've got 1 going to 2, 1 going to 3, 1 going to 4, 1 going to 5, 1 going to 6, right? And then we've got 2 attached to all the other ones. But notice that 2 is not going backwards, so you could put arrows in here if you wanted to, because we're going just in one direction. By the way, these are costs associated with node 1, and then 2, 3, 4, 5, 6. Okay, and then similarly, cell 2 would be going to its attached. It's not going to 1, but it's going to 3, then it's going to 4, and then it's going to 5, and it's going to 6. Right, so similarly, node 3 then would go to 4, 3 goes to 5, 3 goes to 6. We're just about done. 4 goes to 5, and then 4 can also go to 6. Running out of good room there. And then 5 goes to 6. Okay, that wasn't too bad. You can see there's a lot of edges there. Okay, so this one gets a little bit more complicated to solve, but you can put it into a nice network. So, boy, my chair's real squeaky. With this microphone, you're probably hearing it. Okay, so we're just setting this one up for now. We'll try solving it later in 8.2. See you then.